So here we have, we can kind of show an example of what you might see in a QPU networking program in a data center. Here we're showing a trapped ion quantum computer on the left being connected to a superconducting quantum computer on the right. We have transduction interfaces between everything here, and we have a user interface that allows us to specify our computation that we want to perform. So this UI, we can frequently, we call this an orchestrator, so we can orchestrate the whole computation through this easy to use interface. And if this system is a multi-tenant system, then this could potentially also have reservation capabilities. Again, the simulator is very important as a tool, so that you can simulate what you expect. You can kind of compare what you're seeing in the lab with the simulations. You can tune design choices for your hardware before you purchase your hardware. So simulation is important. So here I'm showing just a couple of diagrams from some recent publications around modular quantum computing. So the top diagram shows, it actually encompasses two diagrams. So on the left part of the upper diagram, we have what we call a switch-centric topology of our data center. So this is showing on the top, we have switches that provide all-to-all connectivity between our QPUs, which are shown at the bottom. These switches have a high number of ports. And so essentially, because we're having all-to-all connectivity, this can get a little bit expensive as we increase the scaling of the system. An alternative topology is this server-centric topology, where we have different servers that have some basic quantum operations. We don't have direct physical path connections to each QPU, but we can support that using entanglement routing in our system. And then at the bottom, we have an example of a modular optical interconnect that may be used in a data center to connect different modules or groups of QPUs. And in this particular case, we have, this is called a QFly optical interconnect. And it is showing nodes that are either have entanglement generation sources or QPU nodes. And this, the photons can be routed anywhere to any of the end nodes or even out to another group. So in this case, the photons are emitted, they go around the ring, they can be switched at any node. And in this case, the design is minimizing the number of hops. We also have hierarchical routing, because each of these groups can route to other groups. So this gives a good modular system for routing.